In this part, we'll look at why accidents happen, as well as some ways that you can help to prevent accidents. One of the most important things to remember is that ultimately, you are the one who is responsible for your on-the-job safety. Not the government, not your employer, but you. Generally speaking, accidents are caused by unsafe acts or unsafe conditions. So workers can help to prevent accidents by developing safe work habits. Accidents that result from poor human behavior include accidents caused by a lack of communication, poor work habits, drug or alcohol abuse, and inadequate training. You can help prevent these types of accidents from happening by knowing how to behave on the job and doing it. Many accidents happen because of a lack of communication. For example, you may know the procedures to follow on a particular job, but what happens if you use those procedures on a new job site? You need to communicate with the people at the new job site. Ask questions to find out if they do things the way you're used to, or if there are other procedures you need to follow. And never assume that other people know something without talking to them about it. Assuming that other people will do what you think they will do is a cause of many accidents. For example, if you need to touch wiring, never assume that electrical power has been cut off. You need to make sure, and that includes communicating with others and testing the wiring. Accidents caused by unsafe acts can also be the result of poor work habits. For example, simple carelessness, horseplay, or procrastination can lead to an accident. Procrastination is another way of saying putting things off until tomorrow. Putting off until tomorrow work that should be done today can lead to trouble. If you put off the repair, inspection, or cleaning of tools and equipment, you may stretch their capabilities beyond their operating capacities. This can result in injuries to yourself and others. Now, poor work habits are another part of human behavior that you can take steps to correct. Work habits and work attitudes are closely related. If you don't pay attention to instructions, you may also ignore words of warning. And if you let yourself become distracted, you won't be concentrating on the job. If you aren't concentrating, you could make costly mistakes that hurt you and coworkers. For example, horsing around on the job distracts you and others from concentrating on the work at hand and can lead to an accident. Horseplay on the job is not fun. In fact, it's potentially lethal. Carelessness can be another cause of accidents, especially with tools and equipment. Tools and machines don't know the difference between wood and steel and flesh and bone, so you should always be careful when using them. Accidents also result from alcohol and drug abuse. Every year, alcohol and drug abuse cost industry millions of dollars in accidents, lost time, and lost productivity. Anyone working in an impaired state puts not only himself at risk, but his co-workers as well. In addition to illegal substances or alcohol, many prescribed and over-the-counter medications taken for legitimate reasons can affect your judgment and ability to work safely. If your doctor prescribes any medication that you feel might affect your job performance, ask about it. Your safety and that of your fellow workers depends on everyone being alert and attentive on the job. Now, another reason accidents occur on the job is inadequate training. Never operate any tool or equipment until you've been trained to use it. You can greatly reduce the chance of accidents by learning the safety rules for each job that you perform. In addition to unsafe acts, accidents can be the result of unsafe conditions. One way you can improve work conditions to help to prevent accidents on the job is to practice good housekeeping. Take a moment now to try a question on how you can prevent accidents. This worker is new on the job. He has a bad cold and has taken a decongestant to help him breathe easier. He's about to operate equipment he's never used before. A manual is available, but he thinks he can handle it on his own because he used a similar machine at a previous job. Companies usually have written policies and procedures covering safety practices on their job sites. This part looks at safety policies and their importance in working safely. Most companies' safety policies include very strict requirements for employee behavior. For example, horseplay and other inappropriate behavior can lead to termination. Keep in mind that safety policies are for your protection. The many hazards on a job site require your behavior, whether at work, on break, or eating lunch, to always be consistent with the company's safety policies. For example, It's crucial for all on-the-job injuries, accidents, and near misses, no matter how minor, to be reported according to company policies. Some workers feel that an injury is too minor to report. But any injury, no matter how minor, should be reported. There have been many cases in which minor injuries, such as cuts and scrapes, have become major injuries as a result of infection and other complications. In some cases, workmen's compensation payments have been delayed and sometimes denied because accidents were not reported. Another reason why you need to report accidents is that safety policies are developed, revised, and improved by analyzing accidents. Reporting an accident can and does result in policy changes when needed, and good policies reduce the likelihood of similar accidents happening in the future. In addition, certain on-the-job incidents must be recorded and reported to various agencies such as OSHA, the Occupational Safety and Health Administration. These incidents include injuries, accidents, and near misses. Now, in many work environments, an important safety policy is concerned with evacuation procedures. These procedures are put into effect when a dangerous situation arises. If you work in one of these environments, it's important for you to know the procedures to follow for an evacuation. You must also know the signal that is used, usually a horn or siren, to notify personnel that an evacuation is required. When you hear the evacuation signal, you should follow the evacuation procedure to the letter. That usually means following a prescribed route from your location to a designated assembly area. And you must notify the person in charge when you reach the assembly area. This way they can account for you and not have to send others to look for you. Try a question now to check your understanding of company safety policies. In this part, we'll look at common types of personal protection equipment and see how they're used. Personal protection equipment is what you wear to protect yourself from injury. This part also covers procedures for safely lifting heavy objects. Before you begin work, it's important to consider what types of accidents could happen on the job you're about to do. Using common sense and wearing the appropriate personal protection equipment will reduce your chances of being injured. For example, hard hats are worn to protect the head. Here's a typical hard hat. Its outer shell is made to protect your head from a hard blow. The webbing inside the hat maintains a space between the shell and your head to help cushion your head from any blows to the hard hat. The headband lets you adjust the fit so that the hat fits comfortably and so the webbing is properly positioned. You should inspect your hard hat before use. If there are any cracks or dents in the shell, or if any of the webbing is worn or torn, get a new hard hat. Besides protecting your head, it's also important to protect your eyes. Eye protection such as safety glasses or goggles should be worn wherever there is even the slightest chance of an eye injury. Regular safety glasses will protect you from objects coming at you from the front, and side shields can be added to give protection from the sides. But the best protection from all directions is provided by safety goggles because they totally enclose your eyes. Safety glasses and goggles must be inspected before use and always handled with care. If they become scratched or damaged, replace them. You should also clean the lenses regularly with lens tissue or a soft cloth. Another one of your senses you may need to protect is your hearing. Protecting your hearing requires particular attention because your ears may not always give a warning when they're being damaged. Exposure to high noise levels over a long period of time can cause hearing loss, even when the noise is not loud enough to cause pain. So you should also take steps to protect your hearing. Ear protection is usually provided by using earplugs or earmuffs that are specially designed for this purpose. Earplugs fit into the ear where they can filter out noise. Earmuffs are large padded covers for the entire ear. In extreme cases, both earplugs and earmuffs may be required. Now let's turn our attention from the head to the hands. Many job sites require the use of gloves to prevent injury to the hands. You'll commonly find work gloves made out of cloth, canvas, leather, and rubber. You should wear the kind of work glove that is best suited to protect your hands for the job you're performing. Leather work gloves are used to prevent cuts and scrapes when the wearer is handling sharp or rough materials. Heat-resistant gloves are sometimes used for handling hot materials, and special rubber-insulated gloves are used when work is done on or around live circuits. Be sure to inspect your gloves before each use. If your gloves become worn, torn, or soaked with oil or chemicals, dispose of them properly and get new ones. In addition, rubber gloves used for electrical work should be tested and certified regularly to make sure that they will protect the wearer from electrical hazards. Now let's turn our attention to protecting the feet. Probably the best shoes to wear on the job are approved steel-toed, steel-soled safety shoes. The steel sole prevents nails and other sharp objects from puncturing your feet, and the steel toe protects your toes from falling objects. The next best footwear material is heavy leather. It's important to inspect your work shoes before you put them on. Replace them when the sole tread becomes worn, when there are holes in the upper part, or if they become soaked in oil. Another important type of personal safety equipment is worn to protect you from being injured by a fall. For example, this fall protection system has a safety harness that consists of shoulder and chest straps and leg straps. It also has a D-ring, which is used to attach a lanyard. The other end of the lanyard is attached to a strong anchor point located above the work area. You should wear fall protection when required by your company's work rules. Remember that a fall protection system must never be used for anything other than its intended purpose. Carefully inspect the harness before each use. Make sure that the buckles in the D-ring are not bent or deeply scratched. And check the harness for cuts and rough spots. If you find any damage, turn the harness in for testing or replacement. Of course, all of the hazards on a job can't be seen. One type that frequently can't be seen is a breathing hazard. For protection from this type of hazard, the use of a respirator is required whenever there is a danger of suffocation or other breathing hazard.
Selecting the right screwdriver for the job is the first step in properly using a screwdriver. It's important to select the screwdriver with the right type of blade for the screws you'll be using. Using the wrong screwdriver could damage the screwdriver, the head of the screw, the job, or you.
Now, before using any respirator, you should check it carefully for damage and perform fit checks. Always begin by checking the general condition of the respirator before you put it on. Examine the straps, sealing surface, and gaskets for any cracks. If the respirator isn't in good condition, don't use it. However, if it appears to be in good working order, follow the manufacturer's instructions to put the respirator on and adjust it for a comfortable fit. There are two fit checks that must be performed. One is an exhalation or positive pressure check, and the other is an inhalation or negative pressure check. Let's look at a positive pressure check first. To begin the positive pressure check, you need to block off the air outlet for the respirator. Exactly how this is done varies depending on the type of respirator used. For the respirator shown here, the exhalation can be sealed off with your hand. Then you exhale and maintain a positive pressure inside the facepiece. If the respirator fits properly, you should not feel any leaks around the sides of the facepiece. If there are no leaks, you should perform the negative pressure test. For this respirator, you place your hands over the air inlets. Then inhale and hold your breath to establish a negative pressure inside the facepiece. If the respirator fits properly, it should hold the suction inside of the facepiece as long as you block off the air inlets. And there should be no leaks around the sides of the facepiece. If the respirator fails either one of the fit checks, readjust the straps or harness on the respirator and repeat both checks. But if after several readjustments you still can't get it to pass both tests, you should let a supervisor know and not use the respirator. It's important to remember that even the best protective equipment is of no value to you unless you do 4 things. Inspect it regularly, care for it properly, use it properly, and never alter it in any way.
Once you've selected the correct screwdriver, be sure it's in good condition before you use it. The handle should not be worn or damaged. The blade's tip should be straight and smooth. If it isn't, it needs to be repaired or replaced. You also want to make sure the screwdriver is clean. A dirty or greasy screwdriver can slip out of the screw head or your hands. To use a screwdriver correctly, insert the tip of the blade into the slot of the screw. Holding the screwdriver perpendicular to the work, apply firm, steady pressure to the screw head and turn.
Now, the last bit of personal protection we'll look at concerns lifting. Many injuries occur when heavy objects are lifted. As with most things, there is a wrong way and a right way to lift an object.
Turn clockwise to tighten, counterclockwise to loosen. An easy memory tool is right is tight and left is loose. Although we used a straight blade screwdriver in our example, the steps are the same for a Phillips screwdriver.
If you decide that you can safely lift the object by yourself, stand as close to it as possible, with your feet shoulder width, about 12 to 18 inches apart. Make sure that your footing is secure and that you're well balanced. Then squat down and take a deep breath as you get a firm grasp. Keep your back straight and lift with your legs. Keep the object close to your body at waist level, and be sure it doesn't block your vision. When you put the object down, be sure to use your leg muscles and not your back. Put it down slowly and be careful not to drop it. If a load is too big or heavy, get someone to help you. Following this procedure allows you to use your strongest muscles, which are the ones in your legs, instead of your weakest muscles, which are those in your back. Take a moment now to answer a question about personal protection. In this part, we'll take a look at common worksite hazards, and we'll discuss some general rules and guidelines for worksite safety. Specifically, we'll look at hazards associated with welding, trenching and excavating, proximity work, working around pressurized or high-temperature systems, and working in confined spaces. You should always take care around a welding operation. To prevent accidents from happening around welding, some basic safety guidelines should be followed. Always keep the work area clean and free from dangerous material. And always handle compressed gas cylinders with caution. The acetylene used in gas welding can be dangerous, and the cylinders containing it must be handled with extreme care. Never stare at a welding arc with the naked eye. Light from an arc is so concentrated that sometimes even the reflection of an arc can burn the eyes. This burn damage is commonly referred to as a flash burn. Keep in mind that even a brief unprotected exposure to a welding arc can do serious damage to your eyes. It's also important to note that the symptoms of damage usually may not show up immediately after the exposure has occurred. Symptoms of flash burn include headache, red or weeping eyes, trouble opening the eyes, impaired vision, and a swelling of the eyes. If you think that you may have experienced a flash burn to the eyes, you should get medical attention immediately. If you're the one who is welding, make sure that you use the proper protective equipment. To be properly equipped to weld, you need to have lens shields, a long-sleeve welding jacket, leather welder's gloves, high-top shoes approved for welding, and cuffless trousers which cover your ankles and shoe tops. It's important to remember that a work permit may be required before welding can be performed. It's also important to make sure that someone is present to monitor your work and alert you to potential problems. The person who does this job is often referred to as a fire watcher. After welding is completed, the fire watcher remains to make sure that there are no fires smoldering. The next few worksite hazards we'll look at occur around trenching and excavating operations. Cave-ins and objects and tools falling into an excavation are constant threats. So good job safety around trenches and excavations includes keeping tools, materials, and loose dirt and rocks away from the edges. Excessive weight near the edge of a trench or an excavation could also cause a cave-in. In general, material should be stored at least 2 feet away from the edge of a trench or excavation. To protect everyone at the site, barricades should be placed around all trenches and excavations. And all OSHA regulations and company procedures should be followed for shoring and securing a trench or excavation from a cave-in. You should never work beyond the shoring. And you should remember to check the excavation daily for signs of trouble, especially after a rain, since the water could loosen the dirt. Working near a hazard but not in direct contact with it is commonly called proximity work. Proximity work requires following procedures, caution, and awareness. Hot piping, energized electrical equipment, and running machinery can all be hazardous. In any case, you must perform your work so that you don't come into contact with the hazard. For example, you may need to erect barricades to prevent accidental contact. Energized electrical equipment is particularly hazardous. Regulations and procedures spell out the minimum safe working distance from energized electrical conductors. The distance that must be maintained varies with the voltage levels involved. Many jobs require work to be performed in close proximity to tanks, piping systems, pumps, and other components that contain pressurized and/or high-temperature fluids. Many industrial processes contain fluids at temperatures of several hundred degrees. Contact with components of these processes can cause severe burns. Any work around pressurized or high-temperature systems should be considered proximity work and dealt with accordingly. As the source voltage increases from 0 to its peak negative value, the capacitor is being charged, but in the opposite direction. When the source voltage reaches its peak negative value, the capacitor is fully charged. Again, the source voltage and the voltage across the capacitor are equal and opposing, so current is 0. As the source voltage passes its negative peak, the capacitor again starts to discharge. When the source voltage reaches 0 again, current is at its peak positive value, and the cycle is complete. Now, in the example we just looked at, capacitance was the only factor that affected current and voltage. In a purely capacitive circuit, capacitance causes voltage and current to be out of phase. Because capacitance opposes a change in voltage, changes in current always take place ahead of changes in voltage. Another way to say this is that in a purely capacitive circuit, current leads voltage by 90 degrees. Now see if you can answer a question about the relationship between capacitance, current, and voltage. If a space meets the definition of a confined space and also contains hazards that are immediately dangerous to life and health, it can be classified as a permit-required confined space. Before these spaces are entered, a permit needs to be obtained. Permit-required confined spaces are defined as confined spaces that contain or have a potential to contain a hazardous atmosphere, that contain a material that could engulf or surround a worker, that contain any other recognized serious safety or health hazards, or that is configured so that a worker could be trapped or suffocated. When you're working in a confined space, always follow your company's procedures. Following these procedures may include receiving clearance from a safety representative before starting work. At the minimum, working in a confined space requires that you stay in voice or visual contact with someone outside the confined space, such as an attendant or a fire monitor. Before starting work, make sure that the atmosphere inside the space has been tested for oxygen content, explosive gases, and other hazards. Make sure that you know and follow company guidelines for selection and use of respiratory equipment. While you're working, use only approved electrical appliances, lights, extension cords, and tools. And never attempt to perform a rescue or enter a confined space unless trained and authorized to do so. If an emergency exists, notify the proper personnel. Take a moment now to try a question on safe worksite safety practices. In this part, we'll look at safety practices for working with equipment and materials that are commonly found at work sites. We'll also look at material safety data sheets and at procedures for working safely around hazardous substances. Let's begin with safe practices associated with motorized vehicles. Many types of motor vehicles, such as trucks, forklifts, and cranes, are common to work sites. Working safely around motorized vehicles requires care on the part of their operators, but also on the part of anyone working in their vicinity. The operator of any motorized vehicle is responsible for the safety of passengers and the protection of any load being carried. Using common sense and following safety rules help prevent accidents, and the operator should have a clear view of the road. This means that windshields, rear-view mirrors, and lights should be clean and functional. When operating a motorized vehicle, you should always wear your seatbelt. Also, be sure to obey all speed limits, and be sure to reduce your speed when you're in crowded areas. When you're backing up, look to the rear and sound the horn first. If your rear vision is blocked, you'll need to get someone to direct you. If your vehicle has a backup alarm, make sure it's working. And make sure you turn off the engine and set the brakes before leaving the vehicle for any reason, including to refuel. Now, cranes and other vehicles used to lift loads require additional precautions. For example, another worker may be required to signal the driver about the position of the load or the direction of the vehicle's travel. When we talk about negative power, we mean power that is returning to a power supply from a load. We can better understand what this means by looking at a second type of AC power, reactive power. The next equipment safety procedures we'll look at are concerned with protecting you from potential hazards associated with electricity, flammable liquids, chemicals, acids, and steam. There are several techniques used to put equipment in a safe condition to be worked on. For example, tags and locks may be used to ensure that the status of a system or component doesn't change while work is being performed. In other words, locks and tags are used to make sure that motors aren't started, valves aren't opened or closed, and no other changes are made that would compromise worker safety. Tags and locks are placed on each switch, circuit breaker, valve, or other component that is operated to isolate the equipment. In this way, workers are protected from all potential sources of energy.
In this topic, we looked at some hand tools that are used to turn fasteners. We saw two types of screwdrivers designed to install and remove screws. And we also looked at several types of wrenches. Although wrenches have different designs, their general function is the same, to turn fasteners. Now try some practice questions to check your understanding of screwdrivers and wrenches.
In most lockout procedures, each lock has its own key, and the key is kept by the person who installs the lock. In general, the person who installs the lock is the only one who can remove it. When a device, switch, valve, or piece of equipment is locked out, a proper tag is also attached. Only tags that have been approved for the worksite should be used. And a basic rule of thumb is to never operate any device, valve, switch, or piece of equipment with a tag or lock attached to it. The exact procedures followed for lockout, tagout vary between different companies and work sites, so you'll need to learn about and follow the lockout, tagout procedures used where you work. Another potential safety hazard from which workers should be protected is any opening in a wall or floor. There are two basic ways in which workers are protected from these hazards. The openings are covered or guarded. Any hole in a floor should be covered if possible. When covering an opening is not practical, barriers, which you may also hear referred to as barricades, are used to alert workers to the hazard. For example, barricade tape is often used to alert personnel to hazards in an area. Typically, barricade tape is strung between 2 points, such as between poles. The tape used is color-coded according to its function. For example, red means danger is present. No one can enter an area guarded with a red warning barricade tape. Another commonly used type of barricade is a protective barricade. Protective barricades physically prevent people from passing beyond them. These barricades can be steel fence, wooden posts and rails, posts and chains, or other types of cable. The line current is actually equal to the phase current times the square root of 3. Since the square root of 3 is 1.73, we can say that the phase current times 1.73 equals the line current. You'll need to know this when you're taking readings of current and voltage on three-phase systems that are delta connected. The safe use of equipment at a work site isn't the only safety consideration you need to keep in mind. There are also many materials that you need to work safely around. In order to help protect workers from hazardous materials, OSHA has developed a standard called the Hazard Communication Standard, or HAZCOM for short. This standard addresses the worker's right to know about the specifics of any hazardous materials that he or she may come in contact with on the job. HAZCOM requires that all employers educate their employees about the hazardous materials they may be exposed to, and that employees be taught how to work safely in the presence of these materials. For example, a document called a Material Safety Data Sheet, or MSDS, should accompany every shipment of a hazardous substance and be available to the workers on a job. In a Y-connected system, the phase current is equal to the line current, but the phase voltage is not equal to the line voltage. The phase current is equal to the line current because the current flowing through each line has to flow through the coil or resistor in the line. The phase voltage is not equal to the line voltage because the voltage in each coil or resistor has to be added to the voltage in one of the other coils or resistors to form the voltage across any two wires. In Y-connected systems, line voltage equals phase voltage times 1.73. Now try a question to check your understanding of the material we just covered. Although the MSDS forms you encounter may vary, the information on this type of document includes the identity of the material's physical and chemical characteristics, the nature of the hazard it presents, precautions for the safe handling and use of the material, exposure limits, the reactivity of the material, and specific control measures. HAZCOM also spells out various responsibilities that the worker has. These responsibilities can be summarized as knowing the location of the material safety data sheets at your work site, spotting and reporting any hazards, knowing the potential physical and health hazards posed by any of the hazardous materials on site, knowing and practicing the actions necessary to protect yourself from these hazards, knowing what to do in case of an emergency, and knowing the location of your employer's written hazard communications program. Take the time now to try a question about working safely with equipment and materials. In this part, we'll look at how you can inspect and work safely with commonly used types of ladders and scaffolds. Ladders and scaffolds are used to perform work in elevated locations. Now, anytime work is performed above ground level, there is an increased chance that an accident will occur. We'll begin with a look at ladders. Basically, there are three types of ladders commonly found at work sites: straight ladders, extension ladders, and step ladders. This is a straight ladder. It consists of two rails, rungs between the rails, and safety feet on the bottoms of the rails. The straight ladders used at work sites are usually made of wood or fiberglass. OSHA requires regular inspections of all ladders and an inspection before each use. Another commonly used type of ladder is actually two straight ladders connected, and that's an extension ladder. The two straight ladders are assembled using a mechanism that allows the overlap between them to be varied. This makes it possible to vary the length of an extension ladder to match the needs of a particular job. An extension ladder also has rung locks that support the weight of the movable section and a person climbing on the movable section. When you're inspecting an extension ladder, you look for many of the same things that you look for on a straight ladder. When you inspect the rope that is used to raise and lower the movable section of the ladder, see if it's frayed or has worn spots. If this is the case, it should be replaced. The rung lock should be carefully inspected for damage before each use. If damage is found, the rung lock should be replaced or repaired before the ladder is used. Extension ladders are positioned and secured the same way that straight ladders are. When you adjust an extension ladder's length, always reposition the movable section from the bottom, not the top. And after you make an adjustment, be sure that the rung locks are properly engaged. Now, to ensure its strength, an extension ladder needs a certain amount of minimum overlap between its sections. For example, ladders up to 36 feet long must have an overlap of at least 3 feet. Ladders 36 to 48 feet long require at least 4 feet of overlap, and for ladders that are 48 to 60 feet long, 5 feet is needed. You should never stand on the top step because putting your weight that high will make the ladder unstable. The top of the ladder is made to support the hinges, not to be used as a step. And although the rear braces may look like rungs, they're not designed to support your weight, so never climb the back of a step ladder. The next type of equipment we'll look at is also used to work in an elevated location. Scaffolds provide safe, secure elevated work platforms for workers and materials. Scaffolds are designed and built to high safety standards, but normal wear and tear or accidental overstress can weaken a scaffold and make it unsafe to use. For this reason, it's important to inspect all parts of a scaffold before each use. There are 3 basic types of scaffolds: tubular welded or sectional scaffolds, rolling scaffolds, and suspended scaffolds. Take a moment now to answer a question about the safe use of ladders and scaffolds. Well, in this topic, we looked at actions that can be taken to help ensure worksite safety, including personal protection, safe work practices on the job, safe handling of equipment and materials, and safety practices for working with various types of ladders and scaffolds. Try some practice questions now that relate to this material. Electricity is a form of energy. The movement or flow of electricity is called current. Current is measured in units called amperes, or amps for short. The force that makes electricity flow is called voltage. Voltage is measured in units called volts. Now, all materials offer some resistance to current flow. Generally, current tends to flow along the path of least resistance back to its source. A material that current can flow through easily is called a conductor. Some substances such as copper, steel, and aluminum are excellent conductors. In other words, current flows easily through them. The human body is also a conductor. If the human body comes in contact with a current-carrying conductor and is also in contact with the ground, the body may become the path of least resistance. When the body conducts current and the amount of current is sufficiently high, a person suffers electrical shock. Electrical shock is the body's physical reaction to a significant amount of current flow through it. The prime cause of death from electrical shock is the heart going into a state of convulsion called ventricular fibrillation. When a sufficiently large amount of current flows through the heart begins twitching in an irregular manner. This twitching is ventricular fibrillation. Ventricular fibrillation lasts for only a short time. Without the normal heartbeat rhythm, the individual dies. Of course, not all electrical accidents result in death. Electrical accidents can also result in electric shock, falls caused by shock, as well as burns and other injuries caused by explosions and fires. Now, you don't necessarily have to come in direct contact with a conductor to be injured. You should also be aware that electricity can pass through the air for short distances. When it does, the arc and flash that result generate a great deal of heat that can cause burns, fires, or even explosions. OSHA regulations and your company's policies and procedures are very specific about keeping the workplace safe from electrical hazards. In addition, there are many things that you can do to reduce the chance of an electrical accident. To remain safe around electrical hazards, you need to know the safe working distance that applies to each worksite situation. You must also make sure that you never get any part of your body or any tool you're using closer to exposed conductors than the safe working distance. Information on safe working distances can be obtained from your supervisor, company safety policies, and regulatory documents. Now, if you're present when someone receives an electrical shock, remember that immediate action can be life-saving. If someone is shocked, follow your company's procedures to respond to the situation. These procedures include reporting the situation and disconnecting the circuit. If the circuit cannot be readily disconnected, use non-conducting material to separate the victim from the circuit. Be careful not to touch the victim or the electrical source unless you are safely insulated. You don't want to become another victim. Once the victim is separated from the circuit, provide first aid as required and call for an ambulance. Of course, the best way to provide fire safety is to prevent a fire from starting in the first place. There are several measures that you can take to help prevent fires. Always work in a well-ventilated area, especially when you're using flammable materials such as shellac, lacquer, paint stripper, or construction adhesives. Also, never smoke or light matches when you're working with flammable materials. You should make sure that combustible materials are stored only in approved containers, and keep oily rags in approved metal containers. It's also important to know how to use fire extinguishers. This includes knowing where fire extinguishers are located and what type of extinguisher to use for different types of fires. In addition to fuel, oxygen, and heat, one more thing is needed for a fire, and that's a chemical reaction among all three elements that allows combustion to occur and to continue. If any of the three elements is missing, there cannot be a chemical reaction and a fire cannot start. And if a fire has started, removing any one or more of these elements will extinguish the fire. Fuel can be defined as anything that will combine with oxygen when heat is present. Heat can be considered as anything that will raise a fuel's temperature to what is called the flash point. The flash point is the temperature at which a fuel gives off enough gases to burn. The flash point temperature of many substances is quite low, room temperature or less. When burning gases raise the temperature of a fuel to its ignition temperature, the fuel itself will burn and keep burning even though the original source of heat is removed. The best way to prevent a fire is to make sure that the three elements for a fire to start are never present in the same place at the same time. This can be done for different types of fuel by recognizing and removing at least one of the elements. Many other materials at work sites are referred to as ordinary combustibles, and they can become fuel for a fire. The term ordinary combustibles refers to wood, paper, cloth, and similar materials. The easiest way to prevent fire involving ordinary combustibles is to remove the fuel by keeping a neat and clean work area. If a fire does start, you are not expected to be an expert firefighter. However, you may have to deal with a fire to protect yourself, others, and property. So it's important for you to know the location of firefighting equipment at your job site. And it's equally important for you to know which equipment to use on different types of fires. While you're learning where the firefighting equipment is located, also learn the procedure for reporting fires. If a company fire brigade has been formed, learn how to contact them in case of a fire. Fires are divided into 4 classes, and each class of fire has a different method of firefighting and a different type of extinguisher. Take a moment now to check your understanding of fire safety. Regular safety glasses will protect you from objects coming at you from the front, and side shields can be added to give protection from the sides. But the best protection from all directions is provided by safety goggles because they totally enclose your eyes.
After a component position measurement has been taken and recorded, the shaft assembly components can be removed. As each component is removed, it should be inspected and tagged for identification. All machine surfaces should also be inspected. The shaft nut that holds the outer shaft sleeve in place is removed first, and then the sleeve is taken off. The impeller nut is then removed to free the impellers and other components from the shaft.
For example, a document called a Material Safety Data Sheet, or MSDS, should accompany every shipment of a hazardous substance and be available to the workers on a job. As the source voltage increases from 0 to its peak negative value, the capacitor is being charged, but in the opposite direction. When the source voltage reaches its peak negative value, the capacitor is fully charged. Again, the source voltage and the voltage across the capacitor are equal and opposing, so current is 0. As the source voltage passes its negative peak, the capacitor again starts to discharge. When the source voltage reaches 0 again, current is at its peak positive value, and the cycle is complete. Now, in the example we just looked at, capacitance was the only factor that affected current and voltage. In a purely capacitive circuit, capacitance causes voltage and current to be out of phase. Because capacitance opposes a change in voltage, changes in current always take place ahead of changes in voltage. Another way to say this is that in a purely capacitive circuit, current leads voltage by 90 degrees. In a Y-connected system, the phase current is equal to the line current, but the phase voltage is not equal to the line voltage. The phase current is equal to the line current because the current flowing through each line has to flow through the coil or resistor in the line. The phase voltage is not equal to the line voltage because the voltage in each coil or resistor has to be added to the voltage in one of the other coils or resistors to form the voltage across any two wires. In Y-connected systems, line voltage equals phase voltage times 1.73.